Monday. So Monday at 10:45. Okay, what will be the material covered in the exam? For the material for the exam, these are the topics that will be covered: databases, generics, delegates, LINQ, and a little bit of multi-threading, what I covered today. So LINQ and multi-threading I'll cover today. So these will be the topics for the
will be same location, also same classification or somewhere else?
right here. Okay, let me wait until the camera is ready.
Yes, it's ready.
Right. Okay, so anyway, as I mentioned, the exam will be Monday at 10:45. These are the topics we'll cover on the exam: databases, generics, delegates, LINQ, multi-threading. Okay, these two I will go over today. Delegates we covered last time. Okay, so as we discussed last time, delegates, what is a delegate? The job of a delegate is to be able to point to a function, right? So as it's an object-oriented form of a pointer to a function. Okay, so declaring a delegate, as you guys saw, was extremely easy, one line of code. So for example, if we have, let's say, a class, some XYZ, some method in it, let's say public do something, right? Let's pretend it takes a string as a parameter, right? And it may write something to the database or write something to a file or whatever, right? By the way, I forgot, we also covered file processing. So let me add the file processing to it. Okay. So anyway, if we wanted to be able to point to this function, then we'll declare a delegate. First we create the prototype or the signature matching the function that we are interested in pointing to. So our delegate declaration will be simply one line of code. Delegate, and you can call it something, some name, right? And because this takes a string as a parameter, you'll declare something, let's say string s. It returns void in this example, so here will be void, right? And then all we have to do, once we declare this, just like a class, if you declare a class, nothing is created in the memory. To be able to use it, we have to create an object of it. So somewhere in the beginning of your form or button handler, you can create one object of it. So my del d1 equal to new my del. And now we need to point to it. Now let's pretend I make it static over here, meaning I don't have to create an object of XYZ to be able to call, do something. So then I'll simply say XYZ dot do something, right? And then now if I say D1, this will call the delegate, right? So anyway, delegate concept was extremely easy. So now let me move on to the next topic, which is LINQ, and show you what's the main idea behind LINQ. Okay, before I describe LINQ, I will briefly describe a concept called Lambda Expressions. Okay, purpose of a Lambda expression is to describe a method. A method, remember, also called a function. Once we write a function inside a class, we refer to it as a method. So anyway, once we write a method, the purpose of a Lambda expression is how can we write this method in as short of a syntax as possible, so in a compact manner. So anyway, just to give you background, there's a very famous mathematician, Alonzo, I forgot the last name, Alonzo Church, I think, who did his PhD in this entire topic on how do we describe an algorithm in as small of a syntax as possible, right? So he came up with this concept of Lambda expressions, and in C# they are available. So let me show you how simple they are. To write a Lambda expression. Okay, suppose somebody asks you to write a function that takes the square of a given number. So how will we write that function? First you will create a class, right? So class whatever, compute or whatever you want to call it. Okay. Then you will write a function in a public double square, okay, let's say double x, right? And then you will say return x times x, and then end of the class, right? So to write a simple function like this, how many lines of code we had to write? 1, 2, 3, 4, 5, 6 lines of code, right? Okay, so now using a Lambda expression, we can write the same thing in 1 line of code, okay? So the Lambda expression will look something like this. Okay, so this is what we call the Lambda expression. Okay, so to understand the Lambda expression, think of it this way, this is the input to the function. Okay, so this is the input. Okay, then after the equal to greater than sign, this is basically what is the code that we need to execute inside the function. Okay, so in this case, x times x. Now return is optional. If there's just a single line of statement over here inside your function, you don't have to say return, right? Okay, what if our function is doing a little more than simply 1 line of code? Okay, so what if we were trying to write a function to take the average of 3 numbers as an example, right? So what will our function look like in that case? Sorry, let me leave the class compute as is. Okay, and now let me change this function to take the average of 3 numbers. So suppose our code is something like compute ABG, and suppose int a, so suppose it takes the average of 3 integers in C, right? So what will our code look like over here? Suppose we write, even though we can write it in 1 line of code, let me on purpose write 2 lines of code. So if I say double sum equal to a plus b plus c, and then return sum divided by 3.1. So how will we write the Lambda expression for this case? Okay, how many inputs this function takes? 3, right? So take a look over here, the input part will become a comma b comma c, right? And now because there's two statements over here, if we literally wanted to translate it to a lambda expression, then because there's more than one statement, so you will need begin curly just like we use in a function, right? And then you will say something. I mean, you can still declare double sum equal to a plus b plus c, and then return sum divided by 3.0. Okay, so it's still shorter than having to create a class, then having to write the function, begin curly. However, you can see the benefit starts to reduce if the function is a little more complicated. Okay, so most of the time when we use lambda expressions, we use them in those cases where the function is very simple, just one line of code. Then we avoid having to write a class and then writing the function. So then lambda expression really saves us a lot of code. Okay, right? So now where do we use it? So let's go. So now let me go to LINQ. So LINQ is a technology that was created. It stands for Language Integrated Query. Okay, and the idea behind LINQ was to make operating on data let's say completely uniform, okay? Meaning, see, where does our data come from? Our data could come from a database as an example, right? Our data could come from, let's say, a list or an array list, right? Our data could come from, let's say, XML, even though we didn't cover XML in this course, but XML is also used to represent data, right? And there might be other sources of data. Okay, so right now the way we search for data, right? If it is a database, what language do we use to query the data from a database? SQL language, right? If it is a list, let's say you created a list of students, you will write what kind of code you will write. You will write a for loop for each loop for each student, for example, st, and let's say this is st list. Okay, and then you will say if st.id equal to whatever you are searching for, then whatever, right? So we write loops basically to search for data. If it is stored in an array or in a list or in a hash table or whatever, right? Okay, very similarly, even though we didn't cover XML, if we wanted to search data stored in an XML document, we typically use what's called XPath, which is another XML-based technology. So anyway, the point is that depending upon where the data is coming from, we have different technologies for querying data. Okay, so wouldn't it be nice if we can create one single technology so that it doesn't matter it's database or list or XML, we use the same technique. So that's the idea behind the LINQ. Okay, so in LINQ, okay, we will use basically an SQL-like syntax, okay, to query the data. Okay, now let me give you a simple example. Okay, suppose we created a list of students, so list of student, let's call it st list, right? and we populated it with many students, so stlist.add S1 and S2 and so on. Okay, so pretend we have several students in our list, and now we wanted to know, for example, find a student with a particular ID as an example, right? So instead of writing a loop, now we will write an SQL-like syntax. So our code will look something like this. From S in STList, okay, where S dot ID, so pretend ID is one of the fields in the student class, equal to whatever 1, 2, 3, 4, and select S. Okay, and then this will get stored in some result. Okay, so this is what the LINQ statement looks like for searching for a student with a particular ID. Okay. So if you try to compare it to SQL language, what you will see is it's sort of like SQL written in a reverse manner. Okay. See, if we were writing SQL, pretend SQL can work on a list. In SQL, we always write select, something from whatever the table name, right? Where, and then we specify the where clause. Okay. So if you try to compare the way LINQ is written, what do you see? Does it start from the select statement?
No.
No, it starts from the from statement. So this is our starting point. Okay, so as if we took this part and moved it over here. Right? Otherwise, it's exactly the same. So the select gets moved at the very end. Okay. So anyway, when I was looking at LINQ many years ago when it was introduced for the first time, I said to myself, why are they making our life hard? Why not keep it exactly the same way as SQL is? Okay, meaning leave this select in the beginning. Why put it at the end? So after looking into it a little deeply, I said, oh no, C# is correct. It's the SQL that was created incorrectly. The select really should be at the end. Okay, and let me show you why. Okay, when you are writing, let's say SQL, okay, suppose you are joining 2, 3 tables, right? So in that case, remember we put alias for each table. Okay, so suppose you were joining the you were trying to create enrollment and you wanted to join students table, enrollment table, courses table, right? So so you wanted to say S dot first name, comma, pretend S is the alias for the students table, S dot last name. Okay, let's say C dot course num, right? Then you'll say from students. And then at this time you will give it the alias, right? And then you will do inner join and so on. Okay, but take a look, as you're, because we write it as a string, right? As we are writing a string, okay, as you are typing, because you haven't given the alias yet, as you are typing S dot, okay, is there any IntelliSense in SQL?
No.
No. So you have to really remember, oh, I named the column first name. Okay, wouldn't it be nice, all you have to do is S dot and it gives you list of columns, right? Okay, even if there was an IntelliSense in SQL language, the problem is, as you are typing this so far, you haven't even declared what S is. So obviously, since it doesn't know what S is, there's no way it can give us IntelliSense, right? Now let's reverse the situation. okay, and write it in the LINQ style. So from S in ST list. So as soon as we have written this, what does it mean? S is one of the objects in ST list. And what type is ST list? Student. So what will S be? It has to be a student. Where S dot? So as soon as you type S dot, what will happen? Does it know what S is? Yes, it knows it's a student. So automatically will give you all the choices. Okay. So, however, if we had put select S in the beginning, then obviously if we try to do select, so if it was written like this, select S from whatever, where S dot, okay. So the IntelliSense cannot work because S hasn't been defined yet. Okay, so anyway, in short, if you ever get confused how to write LINQ, just think about SQL and just move the select at the very end. Okay. So now the other thing you need to remember is that when you are writing LINQ, what does it return? Okay. When we say select S, what is it going to return? Okay. And the answer is the or let me try to ask you this. If you write SQL, so if you say, let's say, select something from, let's say, products, pretend products is a table where, let's say, product ID equal to whatever, 1, 2, 3, 4, right? What is it going to return? How many things will it return? Will it return one item? Will it return
one item?
Okay. What if I say where product name like, so product name like something percent, C percent, so, or let me just say C percent, so all products starting with C, so how many records will it return?
3 possibilities.
3 possibilities. One is there's no record, right? Or there's 1 record, or there's multiple records, right? So anytime we issue LINQ or SQL, what I'm trying to say is, especially if we are trying to select something, we don't know whether it will be 1 answer coming back, 0 answer coming back, or more than 1 answer coming back, right? So keep in mind the return from LINQ is always an I enumerable. I enumerable is another interface. Okay. For example, all lists are inherited, or all lists implement the I enumerable interface is an I enumerable sequence. Okay. Or list. Sequence is another word for a list. Okay. So in other words, what I'm trying to say is when we write this LINQ over here, technically speaking, the reply will be from this one as I enumerable, student, and let's call it S result equal to. Okay, so again, if you're confused, think of this as a list. So this is the base for the list. Okay, so our reply will be a list called SRES, or whatever name you give it. Okay. Now, how many items will be in the SRES?
Maybe nothing.
Could be
Maybe
zero,
one and
could be
maybe
null, could be 1, could be more than 1, right? So this is an important concept. Never assume, even though in your mind you are thinking, oh, there's only a single student with this ID, but it is going to reply back to us as a list, right? Okay. So now every time if you have to write I enumerable student or whatever product or whatever, right? It's a little hard to write. So, so C# has another concept called implied data types. Okay. So for example, if I use the var keyword and say s1 equal to hello, okay, what is the data type of s1? String, because I assigned it. So this is same as saying string s1 equal to hello. Okay, so no difference. Okay. Very similarly, what if I say var d1 equal to 2.53? What will be the data type of d1? It will be double. Okay. So as long as there's no ambiguity, we create a variable and initialize it to something, C# will automatically know what data type you are trying to create. Okay. So very similarly, if I say var c1, what data type will be c1? We don't know. So this is not even allowed. You cannot write a statement like this. Okay. So again, because like Java, C# is strongly typed, meaning every variable you create has to have a data type. So as long as there's no ambiguity, you can use var, but if it is ambiguous, it will not be allowed. Okay. So coming back to our LINQ now, rather than saying I enumerable student sres equal to, right? I can simply say over here var sres equal to, which is a lot easier to write than, and is there any ambiguity? No, because anytime we issue a select and a LINQ, it always returns an IEnumerable sequence. Okay, so the compiler will know. So most of the time we'll write like this. Okay, so now the question is, because it's returning a list of students, okay, and we know we only, possibly there will be one answer or null if that student does not exist, correct? So how do we get to the student? So after you issue the LINQ, then the next possibility is you will say student st equal to sres dot, and again, if you're on sit down on the computer, as soon as you type dot, there will be a method available, first or default. Okay, so just like the name implies, first means what? The very first element in the sequence, right? So if there was, what if there's nothing over there in the sequence? Then what's the default value for a student if there's no student?
No.
Null. So first or default either will give us the very first student in the list or null. Okay, so then you will check further if st not equal to null and then do something with it, right? So that's one way of writing LINQ. The other way of writing LINQ is, why write even these two separate statements? So let me give you even a shorter way of writing. So what I typically do is, rather than issuing LINQ, then issuing first or default, this is what I will do. Okay, as I make the LINQ, I will put parentheses around here and then simply say first or default. Okay, so now what will we check? So sres could either be a student or null. So if it's not null, I'll go ahead and use the sres. So you can say sres dot first name or whatever. You can access all the fields. Okay. So this is a typical way of issuing LINQ.
What will happen if I'm not using first or default?
Then this is an enumerable sequence. Then you have to go, obtain the first element to be able to access it, just like I was writing before.
Can we assign SRS to the data grid view directly?
If you don't say first or default, then yes. For a data grid view, once you create a data grid view on your form, suppose you called it DG1, then you can say, so let me go back to the example. Let me issue a different SQL and show you the data grid view. Okay, so suppose you wanted to write, you have a list of students, okay, and suppose that list is called ST list. Okay, so this is basically a list of students. Okay, so obviously if you created a data grid view called it DG1, you can say dot data source equal to ST list and DG1 dot refresh. Okay, and you'll be able to display all the students. Okay, what if you wanted to filter the students so that only those students, let's say, whose ID is between a certain range? Okay, so now let's write VAR. Let's say SRES equal to from, and by the way, whatever variable you pick is your choice. So you can pick S, ST, S1, whatever you feel like it. S and ST list. Okay, where S.ID, let's say, is greater than 9,000 and S.ID is less than, let's say, 10,000. Select S, right? Because now I did not say first or default, so what will it return? What will SRES be? Will it be? It will be a enumerable sequence, right? Or a list, okay? So now what will we do? If we do DG1 dot data source equal to SRES and DG1 dot refresh, okay, it will be able to show all students whose ID happen to be between 9,000 and 10,000. Okay. Okay, so now let me give you a few more examples of issuing LINQ. Okay. So again, when you write the where clause, okay, this where clause is written in C#, meaning if you are comparing two things in the where clause, you have to use two equal to's. If you are ANDing, you have to use two ANDs. If you are ORing, you have to. So this is complete C# style syntax once you write the LINQ statement. Okay. Okay, and just another small clarification. Okay, how was LINQ created? Just a little bit of the background. Okay, LINQ was created first by defining what are called extension methods. So let me introduce one more concept called extension methods, which is a very neat feature of C#. Okay, an extension method allows us to add a method to a class, okay, for which we don't even have the source code, okay? I remember typically if somebody wrote a class called XYZ, right? And let's pretend already has some methods in it, okay? And you wanted to add one more method. What will you do if you had the source code? You will go and add your own method over here, right? Suppose you called it F1. Now you can create an object of this class and call F1 through it. Okay, but what if you don't have the source code? This class was created by somebody and they compiled it, gave us as a DLL. So we have it as a library. We don't have the source code. How can we add something to it? Okay, what will you do in Java? For those of you with Java background?
We import it.
Okay, even importing will not let you, if it's in a jar file, you don't have the source code. Okay.
Create an object.
The best you can do is create a different class and inherit from it. And then, right, so if I inherited another class called, let's say my class, whatever, inherits XYZ, right? And then, okay, and then we can go and add, F1 over here. However, now the only problem is to be able to use it, what do we have to do? We have to create an object of XYZ to be able to use F1, or do we have to create an object of my class to be able to use F1?
My class.
My class. So that's really not the same thing. We want to be able to create an object of XYZ and use F1. Okay, so this is where C# has another capability which is called extension method. So once again, the goal is, even if you don't have the code for the class, you can add a method to it. How? Let me show it to you. Okay, so let's pretend we have a class called, let me give you a simple example, employee. Okay, it has double hours worked. Okay, and the corresponding property, it has a double pay rate and the corresponding property, right? It has public double compute pay, return hours worked times pay rate. Okay, a simple class, one method, one useful method called compute pay, right? And once again, let's pretend this was written by somebody else. They did not give us the code. They compiled it as a library, as a DLL. We can reference this library and use the class, but we cannot go and modify it, right? So using the C# extension capabilities, this is what we'll do. We will create another class. You can call it anything you feel like it. So suppose you call it my extension. Okay. Now, just like we use the static keyword with the method, we also have the capability to use the static keyword before a class. So you will say public static. Okay, what is a static class? A static class is a class where all methods are static. So that's when we use the static keyword before a class. Okay, so anyway, you can create a class, call it anything you feel like it. For example, I called it my extension, my ext, right? And inside it now, you can now write the code to extend any class that you feel like it. Okay, so suppose we wanted to extend the employee class. So now you will say public static Okay, and suppose the goal was we wanted to add one more method over here called compute overtime pay. Okay, so then you will say public static double compute overtime pay. Okay, now the parameters of this method, because the goal is that this method will appear as part of this class, right? So the first parameter of the extension method will always be the class object for the class you are trying to extend. Okay, so you will say this employee, call it EMP. Okay, so basically, once again, the very first parameter, which is written like using this keyword, basically means we are trying to extend the employee class. Okay, now you can write the code. So you can say, for example, double overtime pay equal to 0 if EMP dot hours worked is greater than 40, then overtime pay equal to hours worked minus 40 times pay rate times 1.5. So pretend the overtime pay is time and a half of the regular pay. And lastly, return overtime pay. So as soon as we write this class called myExtension, now anybody can create an object of the employee class, and so anybody can create an object of the employee class. So for example, if you did employee E1 equal to new employee, and if you did E1 dot, you will see the compute overtime pay will appear as if it was part of this class. Okay. So anyway, any class that you have, regardless you have the code for it or you don't have the code for it, if you wanted to add a method to it, you can always do it through the extension mechanism of C#. Okay? And once again, how do we write another method to a class that we don't have the code for? We create a static class. You can call it anything you feel like it. Okay? Second, you add a static method to it. The very first parameter of this method has to be the class you are extending, so that you can access the fields of it. Okay? You can add more parameters over here. So for example, if you wanted to specify and not hardcode that the overtime pay will be always 1.5 times the pay rate, you can always add one more parameter over here and say double overtime rate. So that's the second parameter that we added. First one is the class we are extending. Second parameter is, so let me write it a little cleanly so this will go so that it's less confusing. This employee EMP, comma, double overtime rate. Okay. So anyway, so now instead of times 1.5, we can make it over time rate over here. So the caller will say, for example, 1.5 over here, if they wanted to call, right? So you can put as many parameters as you feel like it in the extension method, as long as the first parameter is the class that you are trying to extend. Okay, so now coming back to how did they create this technology called LINQ? First thing they did is created the mechanism to be able to extend any class. Okay, so once the extension method capability is added to C#, now we can go back and add any method to any class that we feel like it. Okay. So where does LINQ make sense? Obviously, LINQ makes sense when data is involved, right? So the designers of LINQ went to the list class, went to the array class, and started added extension methods. Okay, what kind of extension methods they added? They added, for example, a select method over here to the list, to the array, to the hash table, any class that has potential data in it. They started adding a select method, a where method, an order by method. Okay. Let me see, what else do we do? A join method. Okay, so all these types of things that we use with SQL, for each of those capabilities, an extension method was added to the data-related classes. Okay, so once the extension method has been added, and by the way, once they added the select method, what kind of parameter it takes? It takes a parameter of delegate type. Okay. So now let me give you one more concept, which is a little bit advanced, but hopefully anywhere we can use a delegate in C#, we can also use what is called an anonymous method. Okay. Anywhere we are allowed to use an anonymous method, we can also use a Lambda expression. Okay, as I briefly showed you how to write Lambda expressions, you guys saw that it's very easy to write a Lambda expression. So in the select, obviously you can specify a delegate over here. But what would even be easier to specify a Lambda expression? So for example, again, let's pretend we wanted to write a LINQ statement so that we can find a student with a particular ID. So what will it look like? ST_list is our list, right? Okay, does it have a method called select or where or order by? As I mentioned, they already added all these methods to all the data classes. So they are there to begin with. So if I did ST_list dot where, so where is a method, what does it take? It expects a delegate. And as I mentioned, anywhere a delegate is expected, we can also feed in a Lambda expression. So if I simply said x, or you can pick any variable you feel like it doesn't matter, s s.id equal to 1, 2, 3, 4, for example. Okay, so what does this Lambda expression indicate? Basically means there's a function, the input will be s. Okay, what is s now? See, we are writing this Lambda expression on the list, right? And what type of things list contains?
Students.
So automatically this s will be a student. Okay, so think of it as if we wrote a function which takes student as an input, right? And what is the function doing? Think of it this way, as if I said return, even though I didn't write the return statement, return s.id equal to 1, 2, 3, 4. And if I say two equal to's, what does that mean? I'm comparing. So obviously, it will, for every, so suppose in this list I have S1, S2, S3, S4. So think of it this way. This will keep calling this function for each one of these 4 students. Okay, suppose S1 has an ID 1379. S2 has an ID 1234. This has an ID 1583. This has an ID 1672. Right? So those were the IDs for the students. So what will happen as this where is called? So like I said, this where will basically keep calling on each object in this ST list. So which one one of these will return true? Obviously the second one, right? So think of it this way, once this is done, we will have an IEnumerable sequence which will contain S2, okay? So now, further, if we do dot select and S goes to S, so this is what the LINQ will look like if in terms of the extension methods. Okay, so where basically filters the list, then select further picks the type of data that we wanted out of this list. Okay, so since we said select a student, RES will be a list of students, right? What if I said over here S dot last name? Okay, then can you guess what will it be returning?
Strings.
List of last names.
It will return list of last names. Okay, even though that list will contain one or no item, it will be a list. Okay, so anyway, just to give you the background, the way LINQ was created is, once again, first they created the extension capability in C#. Once the extension mechanism is put in place, which means you can go back and change or add any method to any class. Okay, so they went back. See, LINQ was not available in C# from the very beginning. Okay, in the beginning, C# was very similar to Java. Then they kept adding more and more things to it. So after 4 or 5 years, once they added LINQ to C#, this is how they did it. They went to all the data classes, list, array, hash table, and so on, anywhere data is stored. And they started adding these as extension methods. Once the extension methods were added, now you can call a method, call whatever it returns, you can further call another method on it, right? So this allowed us to basically query the data. But then writing like this is not as intuitive as writing the SQL-like statement, right? So then they basically wrote a translator, meaning if you created a statement like this, VARRES equal to from S in SD list, where S.id equal to 1, 2, 3, 4, select S dot last name. Okay, so what does the compiler does? Remember, there is no such thing in any language like C# or Java or we always write, we always call methods. We We don't write, English language statements like this one, right? So basically, as you try to compile this code, what does the compiler do? It translates this to a series of function calls, like where call, select call, and so on, right? And that's what the compiler executes. So you can yourself write LINQ in this style, but most people, because we are used to SQL language, we find this to be a lot easier than writing it like this, even though internally it gets translated to this form, right? Makes sense? Okay, so now what kind of things can we do with LINQ? You can join things, you can order things. Okay, so now let me introduce one more small concept called anonymous types. Okay, so suppose the goal was like this. Okay, you wanted to display in your data grid view, let's say first name of a student, last name of a student, let's say course number. Okay, so let's pretend 3 things, right? You can add as many things as you feel like it, right? So now let's pretend you went to the database. We have a students table. Okay, and you already populated it in a list of student, and let's call it ST list. So you went to the database using our existing code that you guys already have. You issue SQL, you bring all the students and store them in ST list. Okay? Let's pretend you go to the database, you all the courses that are being offered, you populate them in a list of course. And let's call it C list. Okay? Then you go to the database. Remember, we have an enrollment table. Okay, and suppose you populated in a list called enrollment. So we have ST list, or let me just call it S list, which contains all the students. Courses contains all the courses. E contains all the enrollment, right? Okay, so the goal was, suppose you wanted to, in a data grid view, you wanted to display all students who are registered in a course called CS440. And the fields you wanted to display were first name, last name, and the course number. Or let's call it course name over here, because course number already somebody is specifying. Okay. Let's also add ID over here. So those are the 4 columns we wanted to display. So let me show you how, once we go through LINQ, how easy it becomes to accomplish this thing. Right? So first let's write a LINQ statement. Okay, so our LINQ statement will look something like this. var res equal to from S in S list, join let's see, our second table is enrollment, join key in enrollment on S dot enrollment. If you remember, the enrollment table has an ID and a course number. Okay, so you will say S dot ID equals C dot
E.id.
Oh, sorry, e.id. Okay, then join course C in courses on e.cnum equals e.cnum, where c.cnum equals CS440. Okay, so this will be our LINQ.
E cnum equals E to cnum? Oh, C.
Select. Okay, so I will come to this point. This is not completely correct yet. So I'll talk about this in a second. But for right now, let me leave this statement. So first, let's see, does it make sense? Okay, what was your question?
You wrote E.cnum equals E.cnum.
E.cnum equal to
C.cnum.
C.cnum. Thank you. Okay, so first, let's see if this makes sense, right? Like I was saying, it's again very similar to the SQL language. The only difference is select comes at the very end, right? So take a look over here from SNS list. So what is S? Student. Join E in enrollment. So we'll be joining the students table. So remember, the students table has the ID and all the other, and this is the primary key, this is the foreign key. So basically E in enrollment on. So what are we joining on? The ID in students has to match the ID in enrollment, right? And the only difference is, rather than using two equal to's over here, when we are joining, we use the equals keyword. Okay. By the way, before I forget, there's a handout on the website. It's called something new features in C#. I forgot 4.0 or something. Okay, I'll also put it in our under the video lectures for 2015. It has a lot of examples of LINQ that you should definitely go through so that you are ready for the exam. Okay. Anyway, so let's come and see if we can understand this. So from SNS list, okay, so we join on the ID between enrollment and the student. Then we join the courses between the enrollment and the course, right, on the course number. Okay, so now this will give us essentially up to this point, it will give us all students who are enrolled in CS440, correct? And in the where clause we use two equal to's, right? Okay, so now the question is, what fields do we want to display? If I simply said select S, and, okay, what will it return, by the way?
Student.
An IEnumerable sequence, right? So I forgot to mention one more small thing. So if you wanted, see in the previous example I gave you, the reply was one student or nothing. So I used over here, what? First or default. Here I expect a list, right? So we also have a method available called toList of student as an example, right? And so that's one, I mean, if you really wanted it to be a list of students, you could do this as an example. Okay, however, if I wrote it like this, and then I said dg1.dataSource equal to res, and dg1.refresh, what will show up in the grid view?
Students.
Only student.
It will give us first name, last name, ID, address, telephone.
Yeah.
Will it show us course name?
No.
No. Okay, but we wanted to display course name, right? So now this is where the concept of anonymous types helps us. So most of the time when we are displaying information, we wanted to pick certain fields, okay? You have two options. One option is you create a new class and you call it, let's say, course info display. Okay, what kind of fields you will put over here? You will put in first name, last name, course name, student, right? So you'll put those 4 fields over here. Then rather than saying select S, what will you say over here? You will say select new course info display. Then remember, using curly braces, we can get the construction capability. So then you will say first name equal to S dot first name, correct? Comma, last name equal to
That's last name.
S dot last name, right? And so on. So that's one way of selecting what kind of list we will create. And now you can say dg1 dot data source equal to res and dg1 dot refresh, correct?
Yeah.
So this would be one way of doing it. What's the disadvantage of this technique?
We are adding a class.
You have to add a class corresponding to these 4 fields. What if tomorrow somebody comes and say, oh no, we also want credit hours over here to be displayed? So then what do you have to do? You have to go back and add one more field over here, right? So again, that's an option, but a better, so if the goal was simply to display certain fields, okay, C# allows us to create a type on the fly without giving it any particular name. So if you simply said over here, select new, okay, don't give it any class name. Take out the class name. So you're not writing any extra class. Okay, now start creating any field you feel like it. First name equal to S dot first name, last name equal to S dot last name. Suppose you wanted to call it course name equal to C dot course name, comma, credit hours equal to C dot credit hours, right? So once we create a new, but we don't give it any name, okay, that's called an anonymous type, meaning it's a data type. We never gave it any name, okay? So especially for display purposes, the anonymous types make it very easy for us. We can create any field on the fly and then bind it to a grid view and display it, okay? So I was going to cover multi-threading, but time is short, so let me not cover multi-threading on the exam. So once again, there's a handout on new features in C#, where all these concepts of extension methods, LINQ, anonymous types, all of these are explained through simple examples. So that handout, new features, will be very important, and I'll put it in our video lectures link as well, so please go through it. Once again, reading, again, for those of you who didn't do as well in the first exam, just reading the handout will not make you do well in the exam. Okay, as you are going through this handout, sit down on the computer, whatever example I show you, create it, slightly change it so that you fully understand what's going on, right? Okay, good luck on the exam. And also for those of you who have not stopped by to pick up your exams, I have another class, so you guys can stop by around 12:15 for your exams, okay? Or around 12 will be good.